Circuit diagrams, some of the symbols you may run into if you're looking at a schematic chart. The battery is usually with this symbol down here. It looks like a short line and a long line, a short line and a long line. A lot of times they'll put the negative and the positive charges along theirs as well. Of course, the wire would be the individual line. Here we see another battery over here with one long line and one short line. These right here, these little circles with X's, a lot of times they'll put that in as a type of load, often a light bulb of some sort. That's the device you're trying to run in the circuit. And of course the switch right here would be indicated by this. In this case it's open, so this will be an open circuit, but this will be the symbol for a switch. And sometimes you'll see these little squiggly lines, and what these are called resistors. And what a resistor does is it slows down the flow of electrons. And why would you want to do that? Well, sometimes if you have, like, say in your car, you have a 12-volt battery, but you've also got little light bulbs in your car that can't handle 12 volts, and so you need to decrease the voltage. You need to drain it down a little bit before you try to run it through that little bit of light bulb, or else you're just going to blow out the light bulb. And so you put these things called resistors in line, and they have this little squiggly line, and they often give the resistance, like this is 100 ohms. That's the resistance. This is a 300 ohm resistor and a 50 ohm resistor, and these are all in series right here. This ties into Ohm's law, which Ohm's law is the relationship between voltage, I, which is current, and we measure that in amps, and the resistance we just talked about, and we measure that, of course, in ohms. This equation just says that if I was to increase resistance, what you do is you slow down the voltage that is coming through there. The amps would decrease as well. So it's the relationship between voltage, amps, and resistance. Say if I increase this battery, if I made the voltage higher, then even with these same resistors in here, it's going to be able to push more electrons through because now I've got a bigger battery. So if the resistance stayed the same, if I increase voltage, then the amperage would go up. I would be able to squeeze more electrons through those resistors. Even though they're trying to slow it down, a bigger battery is just going to be able to push it through more. So the voltage is the force pushing those electrons through. The amperage is the amount of electrons that you're pushing through the material, and the resistance is what it sounds like. It's the resistance to that flow. It's trying to slow things down.